Okay, so this is part 2 of the section 4.2 video. So in section 4.2 we were looking at quadratic functions and applications. And so here in part 2 of this video we're going to be looking at applications. So when we're talking about applications, we're looking at those financial applications. The revenue, cost, profit, break even, supply, demand, market equilibrium. All of those applications that we did with linear functions. And they are the exact same with quadratic functions as they were with linear functions, except you have quadratic functions now. But again, the processes are all the same. So remember when we were looking for the revenue of a function, we found the revenue by taking the selling price and multiplying by X, by the number of units. The C of X was the cost function. We found the cost function by multiplying the variable cost times X plus the fixed costs. And then the profit, we found the profit by taking the revenue and subtracting the cost. And remember, you end up having to distribute your negative there. We find break-even point the same way. Remember, we found break-even point. The break-even point was when profit was equal to 0 or when revenue was equal to cost. So either way gets us the same profit. When we were looking at supply and demand, remember, supply relates the quantity that manufacturers produce to the price. And the demand relates the quantity that consumers purchase to the price. And then we could look at those together and we could see market equilibrium, which is when the supply equals the demand at a particular price. The only new application that we can use with quadratics is this last one here. When we're looking for a maximum or a minimum, maximum profit, minimum cost, something like that, remember the maximum or the minimum of a quadratic is the vertex. And to find the vertex, remember, we use x equal negative b over 2a to find the x coordinate, and then we plug that in to find the y coordinate. The y value is the actual maximum or minimum value, where the x value is when it occurs. So the x tells us when that max or min occurs, and the y tells us what the max or min is. So here's a couple of examples. On this first one, we're looking for the daily profit from the sale of a product is given by this function. P is equal to 160x minus x squared minus 6100. Now, we might want to turn that around and write it in the order we like first. So notice when we do, we'll have P is equal to negative x squared plus 160x minus 6100. And we're asked what level of production will maximize profit. So notice we're looking for a maximum. We're looking for the vertex. And so we've got it graphed over here so you can kind of see, the vertex. With our a being less than 0, then we know our parabola opens down and our vertex is a maximum. So if we're looking for a maximum, we're looking for that vertex. But remember, the x of the vertex, the x-axis here is the number of units, where the y-coordinate of the vertex is going to be the y-axis here, which is the profit. So of that vertex, whatever the point is, the x tells us the number of units, the y tells us the profit. So on A, we're looking for the number of units, the level of production, and on B, we're actually looking for the maximum profit. So on part A, we're going to be looking for the x coordinate of the vertex. So we find that by doing negative b over 2a. And so we get negative 160 over 2 times negative 1. So negative 160 over negative 2 gives us 80. And we can see that at 80 units, because remember this is an x, this is a number of units, at 80 units is where our maximum will occur. Notice that doesn't tell us what the maximum profit is. That just tells us we will have our maximum profit when we produce and sell 80 units. To actually find what the maximum profit is, remember we're looking for the y-coordinate of this point. So to find the y-coordinate of the vertex, we plug the 80 back into the equation. So we get the negative 80 squared plus 160 times 80 minus 6,100. And so simplifying that, we get 300. So that tells us that our maximum profit is $300, and we produce that maximum profit when we produce and sell 80 units. And again, we can see that here. This point then, the maximum would be the point 80, 300. And so we can see that at 80 units, we have a profit of $300. More examples on the next page. Here we have the fixed cost of a certain product is $27,850, and the variable cost is 1/4 X minus 150 per unit. We want to find the cost function. So remember, the cost function, C of X, is equal to the variable cost times X plus the fixed cost. So we know that the variable cost is 1/4 X minus 150. That whole thing is our variable cost. So 1/4 X minus 150 is what goes in place of variable costs. And then our fixed costs are the 27,850. So there's our fixed costs. These are our variable costs. So when we're plugging into our cost function, we plug in this whole thing for our variable cost, 1/4 times X minus 150. But then remember, we have to multiply the variable cost times how many units. And so we want to multiply that whole thing times X. And then we can add the fixed cost, the 27,850. All right, so to simplify, we're going to need to distribute the X. And so we end up with 1/4 X squared minus 150X plus 27,850. And so notice this then is our cost function. And so our cost function became a quadratic function when our variable cost was linear. Instead of our variable cost just being a number, we actually had a linear variable cost, and when we multiplied it by X, we ended up with a quadratic for our cost function. And so now we're asked to find the minimum cost. Well, remember the minimum. Notice our A here is positive, so our parabola is going to open up, which means we're going to have a minimum, which is the vertex. So anytime we're looking for minimum or maximum, most or least, we're looking for the vertex. So to find the vertex, we do negative b over 2a. So x is equal to negative b over 2a. So we get negative. Our b, we're looking for minimum cost, so we're using the cost function. Our b is negative 150. Our a is 1/4. So when we simplify, we get positive 150. 2 times 1/4 is 1/2. 150 divided by 1/2 is 300. And so x equals 300, but remember, that's not the cost. The cost is the C. The x is the number of units. So this tells us we will have our minimum cost when our number of units is 300. In order to find the minimum cost, we have to find the cost, the C, associated with an x of 300. So we're going to plug 300 back in to find the C. So 1/4 times 300 squared minus 150 times 300 plus 27,850 gives us a cost of $5,350. And so that would be our minimum cost. All right, the next problem is one that I would like you guys to try. It's got a lot of parts to it, but go on ahead and pause the video. See if you can find and simplify the profit function. The company has a revenue of 400x minus 2x squared and a cost of negative x squared plus 200x plus 1900. Both equations are valid on the domain 0 to 100. See if you can find and simplify the profit function, find the break-even point, and then find the maximum profit. All right, so let's see how you did. If we're looking for the profit function, remember to find the profit function. We do revenue minus cost. And so our revenue function is the 400x minus 2x squared. And then we're going to subtract, and we do need parentheses because we're subtracting the entire cost function, not just the first part of it. Which means we have to distribute the negative. So again, we're subtracting all parts of the cost function. So distributing the negative, we get a positive x squared, a minus 200x, and a minus 1900. And then we need to combine our like terms. When we do, we end up with a negative x squared, 200x, and minus 1900. And so there's our profit function. To find the break-even point, remember we can find the break-even point either by setting the profit function equal to 0 or setting the revenue function equal to the cost function. Either way works, you get the exact same answer. So if we set our profit function equal to 0, we have 0 is equal to the negative x squared plus 200x minus 1900. Notice if you had set your revenue function equal to your cost function, the first thing you're going to do is get it equal to 0, and it's going to end up looking like this. Now we can either solve by factoring or using the quadratic formula. If we're going to try to factor, we probably want this to be a positive x squared. So again, multiply through by a negative or divide by a negative or move everything to the left. We end up with x squared minus 200x plus 1900 is equal to 0. And then it factors. Again, if you don't see how it factors, you can do the quadratic formula. You'll get the exact same results, but this one does factor into x minus 190 and x minus 10. Setting them both equal to 0, we end up with x equal 190 and x equal 10. So we got two answers. But remember, in our problem, they tell us that these equations are valid on the domain 0 to 100. So this only works when our x's are between 0 and 100, which means this is not going to work for 190. It's outside of our domain. So x equal 10 is going to be our only valid solution here. And then part C says, what is the maximum profit? Notice again, our A is negative, so we have a parabola that opens down, which means we're going to have a maximum. And so when we're looking for the maximum, we're looking for the vertex. We find the vertex by doing x is equal to negative b over 2a. So we get negative, and we're looking for the maximum profit. So back in our profit function, negative b would be negative 200 over 2 times our a is negative 1. So we get negative 200 over negative 2, which gives us positive 100. But again, remember, x is the number of units. So this isn't our profit. This is how many units we have to produce and sell in order to have our maximum profit. To find our maximum profit, we have to find the p, the output, the y coordinate that corresponds to an x of 100. So we plug the 100 into the profit function. So negative 100 squared plus 200 times 100 minus 1900, and we end up with $8,100 for our maximum profit. All right, one more application on the next page. Consider the following supply and demand equations. We've got the supply, P is equal to Q squared plus 8Q plus 16. The demand, P is equal to 216 minus 2Q. So part A says consumers will purchase a quantity of 15 units at what price? Well, remember, the supply tells us what the manufacturers are willing to produce, and the demand tells us what the consumers are willing to purchase. And so if we're looking for how many will the consumers be willing to purchase, or they're willing to purchase 15 at what price, we're still looking at consumers. We're going to be using the demand function. So they give us a quantity of 15. We're looking for price. So we're going to plug in 15 for Q and solve for P. So 216 minus 30 would give us $186. So at a price of $186, we as consumers are willing to purchase 15 units. Part B, the manufacturers will produce a quantity of 15 units at what price? So this time the other function, the supply function for the manufacturers. Again, we're looking for the price, and we have a 15 for Q for our quantity. So 15 squared plus 8 times 15 plus 16. That gives us $361. So their manufacturers are willing to produce 15 units when the price is $361. Part C says at a price of $49, manufacturers will produce how many units? So again, manufacturers, we're looking at the supply function. This time they give us a price of $49 and they ask for how many units. So we're looking for Q. We're going to plug in 49 for P and we're going to solve for Q. Again, it's a quadratic because of the squared, so we know we have to get it equal to 0 first. So subtract the 49, we get Q squared plus 8Q minus 33. And then again, either factor or use the quadratic formula. This one does factor as Q plus 11 and Q minus 3. Setting them both equal to 0 and solving, we get Q equals negative 11 and Q equals 3. Now the problem is, this is how many units manufacturers are willing to produce. Can manufacturers produce a negative amount of units? No, that doesn't make any sense, right? So we can rule out the negative 11 and we just get the answer of 3. So at 3 units, manufacturers are willing to produce 3 units at a price of $49. On Part D, at a price of $49, consumers will purchase how many units? So again, consumers are the demand function. Again, we have a price of $49 and we're looking for what's the Q this time. And so we plug 49 in for P in the demand function. Now this one's linear, so we're not trying to get it equal to 0. We're just trying to solve for Q. So we want to get everything on one side and Q on the other. So we subtract the 216. So we get negative 167 is equal to negative 2Q. And then we divide by negative 2 on both sides and we get 83.5 equals Q. All right, so at this point you think, well, do we need to round that up? Can we have half a unit? Well, it depends. Now, they didn't tell us what these units are. Obviously, if you're making something like a cell phone or a TV, then no, we can't have half a unit, and so we would maybe want to round up or down, whatever the situation called for. But we don't know what these units are. It's entirely possible that these units are cases of Coke. We could buy half a case of Coke, right? Or maybe this unit is pounds of sugar. Can't we buy half a pound of sugar? So we don't know what the units are. So since we weren't told, we're going to assume that it's okay to buy half a unit. And we're going to say 83.5 units would be the quantity that consumers are willing to purchase at a price of $49. All right, so Part E is asking for the market equilibrium point. Remember, the market equilibrium point is when the supply and the demand are equal for a certain price. And so since we have both of these equations set to P already, we know that these prices, if we want these prices to be the same, that would indicate these have to be the same as well. So that tells us we can just set the two equations equal to each other. And so we end up with Q squared plus 8Q plus 16 is equal to 216 minus 2Q. Now again, it's a quadratic because of the Q squared, so we got to get it equal to 0 in order to solve. And so we're going to move everything over. We're going to subtract the 216. We're going to add the 2Q. So we end up with Q squared plus 10Q minus 200 is equal to 0. From here, we can factor or use the quadratic formula. And so this one factors as q plus 20 and q minus 10 equals 0. Again, setting on both equal to 0 and solving, we end up with q equal negative 20 and q equal 10. Now again, we don't know what the units are, but we know we can't produce a negative amount of units. That doesn't make sense. So we can rule out the negative 20 and keep just the q equal 10 as our answer. But remember, with the market equilibrium point, you're going to have a quantity and a price. It's going to be the same quantity for the supply and demand when the price is the same. So we have to figure out what the price is as well. Now you can plug that q back into either one of these functions and they should both give you the same price. That was the whole point of them being equal. So let's pick the demand function just because it's easier. It doesn't matter which one you plug it into, you'll get the same result. But if we plug it into the demand function, we end up with P equal to 196. And so remember, when we're writing our point, it's always Q followed by P. And so our market equilibrium point would be 10,196. And that tells us that at a price of $196, the manufacturers and the consumers are both willing to do 10 units. We're willing to purchase 10 units as consumers. They're willing to supply 10 units as manufacturers when the price is $196. So when graphed, this is what it looks like. Now we can tell the difference between the two functions pretty easily. This one is a linear function. It's a straight line. So it's got to be our demand, the demand function, which was the P equal 216 minus 2Q. Because it's linear, because it's demand, it's got a negative slope. Remember, demand is always going to be the decreasing function, which leaves this other one being our supply function, which you'll notice our supply function is a quadratic, and what we have here kind of looks like half of a quadratic. You could imagine that it kept going this way and curved back up so that we had this really wide spread out U-shaped parabola. But we only need to worry about what's going on in the first quadrant because with numbers of units, with profit, it's going to have to be a positive Q. So we only have to look at what's going on over here. And so notice the point here where they intersect. This is our market equilibrium point. This is the point 10,196. It's where we have the same price at the same quantity on both curves. All right, that concludes section 4.2.